In this video, we're going to use interval notation to identify the domain and range of functions, and those functions will be presented in various ways. We'll graph functions of various types, and we're going to graph a scatter plot and use linear regression when given a set of data to make predictions. So first, let's just start talking about graphs of functions. They can be graphed by either using a table of values or a calculator if you have a graphing calculator. Desmos.com is an online calculator you could use if you don't have a TI-84 or another TI or other graphing calculator at home, as a way to kind of check your work. But if you need to graph by hand, a table of values is a good method, particularly when given a function that you're not familiar with. Recall that f of x is function notation, which would have the same meaning as y. It replaced that variable, or the dependent variable. So in the first example we're going to look at is to graph a linear function 2x plus 1. The table of values could be helpful to you, but you might recognize that this is already in slope-intercept form, y equals mx plus b, where the slope is 2 over 1 and the y-intercept, or I like to call it the starting point, is 1. And so you might choose to graph this one, y and x-axis. This is 5, and I've labeled my scale kind of going by ones, but by putting that number halfway through each of these axes in the quadrants there, it helps with counting to find things easier, so I do that a lot. Here we go. So the starting point, or the y-intercept, along the y-axis was 1, and then it has a slope where we rise 2 and run 1 in the positive direction, which is to the right, and kind of repeat that process all the way through. If we were to fall 2, we would move left or in the negative direction 1 and repeat that process, and you'll see the line continues from there. Now, this graphing on this tablet connecting these points is going to be challenging on all of the graphs that I have to do here for you in this video, but I will do my best. You may not have graphed this way. You might choose to use the table of values, in which case you would substitute the -1 originally in for x and say 2 times -1 plus 1. Alright, and that's -2 plus 1 is -1. So -1, -1 is one of our points. This is like your ordered pairs in that table, and you'll see -1, -1 was one of the points on that graph. The next graph that we're going to take a look at here is a quadratic function, which is going to give us a parabola, the shape of that, kind of that U-shaped graph, and we know because of the x squared. Again, several ways to graph this, but the table of values is helpful. So we use the table of values here and substitute the x value of -2 in, so -2 squared minus 3. -2 squared is +4 minus 3 equals 1. We substitute -1 in, so -1 squared minus 3. Well, that's a +1 minus 3 is -2. Substitute 0. 0 squared minus 3. It's going to be 0 minus 3, or just -3. I suggest continuing this table of values, and you'll see we'll put now a +1 as we just keep increasing the x values by 1. So 1 squared minus 3 is going to be a 1 minus 3, which is negative 2. And the reason I wanted to kind of continue that table is with a parabola, we want to find the vertex. The vertex is that low point or high point where the graph will approach and then turn from. And you see this y value of negative 2 matches this y value of negative 2. Therefore, this point right in the middle is going to be our vertex. You'll see that graphically here in just a moment. Let me go ahead and label the axes and our scale. So 0, negative 3 is going to be the vertex, and you can see that at the negative 1, negative 2, or at 1, negative 2. You could also see that negative 2, 1, and so then at 2 you would also have a point 1 because these parabolas are symmetrical graphs. It's helpful also to graph completely through a given coordinate grid if there is one. So we should find the point negative 3. Which is going to be at 6. And then at 3 there is a point at 6. And that actually will get us completely out of this graph now. So again, I'm going to do my best with this tablet to graph. And there's your parabola. The next graph we look at is going to be a square root function. Y, X. Get our scale on there. And we'll use that table of values. So the square root of 1 minus 1, or the square root of 0, is 0. Next, the square root of 2 minus 1, or the square root of 1, is 1. The square root of 5 minus 1, or the square root of 4, is 2. And lastly, the square root of 10 minus 1, or the square root of 9, is 3. So the x values were fortunately given to us in a way that gave us perfect squares, and we don't have to deal with finding decimal or like fractional portions of this very small grid. So 1, 0, 2, 1, 5, 2, and 10, 3. This is just the top half of a sideways parabola, so the arrow would continue to the right forever. But this is a starting point at 1, 0. If you were in your calculator to graph this, you would see error messages for the y values below an x value of 1, or that would correspond to those, because then it would no longer be a function. And you could see that here the square root of, let's substitute 0 minus 1, that's the square root of a negative 1, and that answer is not in the real number set, which is why your calculator would give you an error message for that value. The next graph that we will look at is an absolute value curve, or absolute value function. And so we use the table of values. The absolute value of negative 2 plus 3. The absolute value of a negative 2, or the distance from negative 2 to 0 on the number line, is positive 2 units, plus 3, so that is 5. Negative 2, 5. Negative 1, the absolute value of that plus 3 is 1 plus 3 or 4. The absolute value of 0 plus 3 is 0 plus 3 or just 3. We substitute in 1. The absolute value of 1 plus 3. Well, the absolute value of 1 is 1 plus 3 is 4, which is the same math that we had for negative 1. And then 2 is going to be the same as negative 2. And so if we follow that pattern and continue, that was the wrong one. I'll fix it now. There it is. 1, 4, 2, 5. And if we continue that pattern, that next point was going to be 3, 6, and 4, 7, 5, 8, 6, 9, 7, 10. And unlike the parabola, which has like a letter U shape, the absolute value curve has that letter V shape. Scatter plots now. A scatter plot or scatter diagram is the graph of the ordered pairs in a relation. Scatter plots can show patterns and trends in data, and they're used often in science, in business even, and various other professions where they're looking to analyze a given set of data. So in this first thing, we're looking at the profit of a small car detailer in thousands of dollars. And we've looked at 1 month, 3 months, 6 months, 7 months, and 11 months at that profit. So we're going to work on a scatter plot here. Well, the month is going to be the independent variable x, and the profit would be the dependent that would go along the y. These also are graphs that will only be graphed in the first quadrant generally. So we can put our x and y axis along the left side and the bottom. This will be months, and this is profit in thousands. So we've labeled the axes. Now we just need to get our scale. So we have to go far enough that we can get 11 months in. So I'm going to go 1, 2, 3, kind of by halves. And that just puts us outside. So let's try let's just go by ones. So 1, 2, 3, 4, 5 months, 10 months, 15 months, and 20 months. And then on the profit side, we need to get up to 21,000. And so we could again just go by ones here, since there are 20 blocks, 21 will be just up here. So that's 20, 5, 10, 15. Perfect. And then we're going to plot our points now that our graph is set up. So 1, 2, 3, 6, 6, 11, 714, and 1121. These points will not create a straight line, but a straight line could go between them, and that's going to be challenging for me to do without a ruler on this tablet. If you were to use your graphing calculator and you have a TI-8234, any one of those, you can go to the button Stat and then choose Edit and enter your X values in list 1 and your Y values in list 2, and notice this spells cell as a way to remember. This is how we're going to enter the data into our calculator. To find the regression line, you're going to sell some cool lemonade. How you calculate the regression line is, again, go back to that Stat button. C is hit the right arrow to calculate, and then go down to, I believe, number 4 is linear regression, lin reg it says, for linear regression. At this point, the buttons that you would push in the calculator vary based on the version of calculator that you have. So if you just hit enter here, it will calculate the equation, but there are several different keystrokes that you could hit to be able to have the equation typed unrounded directly into y equals for you, which makes for a really nice graph. Also allows the calculator to do the predictions for you. Let's go ahead and answer these questions here. Does the scatter plot represent a function? Why or why not? Well, if we were to draw vertical lines through any one of those points, we would not hit another point. So yes, it is a function because it passes the vertical line test. And we want to use that scatter plot to approximate the profit in month 14. Well, if you were to just take a look, this particular graph makes it challenging. At 14, we know we're going to be somewhere up here, but I don't know exactly how far that is. It's going to be a little past 25 probably, maybe 26, 27,000. You might be able to kind of make a guess in that way, or to be more accurate, we'll use the calculator or the equation that was given to us in the calculator, and we would substitute 14 in for x if you wanted to work on that by hand. So you would say, let me pull up the equation here. Y equals 1.9020270270 times 14 plus 0.148648646. And this is kind of unrounded. I've written out large decimals to make sure that my answer is as close as possible to accurate on the prediction, where if you had put the equation unrounded into y equals, you could then look in the table, go to the x value of 14, and there you would see the y value is 26.777. Since the profit, which was represented in the y values, is in thousands, the answer here, unrounded, perfect, as exact as possible, would be $26,777. So kind of eyeballing it on the graph, we came up with about 27,000. using the calculator to come up with an equation to make that prediction, we found that it was really close to that 27,000. If we're using the scatter plot to approximate which month the profit would be about 18,000, that one does fit on this graph, so we can go to profit of 18,000, which is right here, and figure out where that line that's sort of imaginary here would come through that graph. And I'm gonna say somewhere here, maybe in this range. And as we follow that line down, that's right around at the 9th month. If you used your calculator and you were in the table function, you would scroll down or up, depending on where you are, to see in the Y values where does it get close to 18,000. And you'll see in the 9th month there you are at 17.267, and the 10th month begins at 19.169. So 18,000 is somewhere between that 9th month and the 10th month. So the eyeball prediction or the calculator here gave us about 9 months. Hopefully in this video you've been able to get a better understanding on how to graph functions, particularly if you're not familiar with what a particular function will give you graph-wise. The table of values is a helpful tool for you to be able to get that basic graph by hand. Also here, getting a kind of an intro to scatter plots and how we might use them for predictions.